So our topic for today is centripetal force or circular motion. So what is a roller coaster? Stay on track, upside down on a loop. Okay, so what we see here, it's inertia that keeps you in your seat. So inertia is the force that presses your body to the outside of the loop. Okay, and as the train spins around. So although gravity is pulling you toward the earth, like always, at the very top, the acceleration force is stronger than gravity. And it is pulling upwards. And thus counteracting gravity. So force pushes inward, as seen here, and inertia keeps going on this way. It's almost tangent to the line. We'll talk about that. So centripetal force is any force that causes an object to move in a circle. So the force is always perpendicular to the object's motion. So the object is moving in a circle, as shown in the red line here. So force is going to go inwards, perpendicular. So again, perpendicular, perpendicular. So force is always directed towards the center of the circle in which the object moves, while the motion will continue on in a straight fashion. So imagine you tie a ball to the end of a string and you swirl it over your head, like in this picture. The force on the ball is going to be moving towards you while the motion is still circular. So objects moving in a circle still have that linear velocity. Remember, to calculate velocity, we did distance over time. So this is often called tangential velocity, since the direction of the linear velocity is tangent to the circle. So to review this topic, a tangent line is going in a straight line, and it just touches that curve of the point. So here. So this would be a tangent. If I kept moving, let's say to the right, there would be another tangent line here. And then I keep going, there would be another tangent line there, and another tangent line here. So if I let it go at this point here, if I let it go here, it would move on to the right. If I let it go at this point, it would continue moving on straight down. If I let it go at this point, it's going to keep going left. If I let it go at this point, it's going to keep going up. So a ball is whirled on the end of a string with constant speed when the string breaks. Which path will the ball take? So first of all, let's review force. We know force itself is going to be pushing this way, force. But this is asking us for the motion. Which way is it going to go? Remember, it has to go tangent to that position. So if we let it go at A, it has to go tangent to A. So the only line that's tangent to A is 3. Can't be 1 because it can't just spontaneously shoot out from 1 and 2. 4 is continuing the motion, but not 4 is continuing the motion if it was still attached to whatever force is here. But 3 is the tangent line, so that's going to work. So again, here, for example, if the string breaks at this point, it's tangent at that point. So if we were to continue on, let's say moving this way, if I let it go, it would go this way. If I let it go here, it would go that way. Let it go here, it goes down. So centripetal acceleration is the acceleration of an object moving in a circle due to a centripetal force. So for example, in this picture, even though it's still moving in this circular shape, velocity is still going at whatever direction you're going. Acceleration is pulling inward. So the formula for our centripetal acceleration is A, and it still has the unit meters per second squared, over v squared. V is your speed in meters per second, and r is your radius, m. So for example, a motorcycle drives around a bend with a 50-meter radius at 10 meters per second. So 50 meters radius is my r, or radius, and 10 meters per second is my speed, v. Find the motorcycle's centripetal acceleration. So A is equal to v squared over r. So v squared would be 10 squared over r, which is 50. So this is 100 divided by 50. So our acceleration is 2 meters per second squared. So again, force or acceleration is pointing this way, and our velocity continues to move on. So you should label this on your notes velocity, and this is acceleration.